9. Okay, so this is 15 on 480. So we have d of x equals 7.5 x squared minus 60.5 x plus 254. Find Beth consumer surplus if she makes 2 jumps. Okay, they're not asking for the equilibrium point yet. That's what I mentioned earlier. We can determine the consumer surplus for any x. So find Beth consumer surplus if she makes 2 jumps. Okay. So x equals 2 jumps. I have to find the cost, the demand for 2. Why? Because I need to find the point. This is not an equilibrium point, but I know x is given to us and y is d of 2. But I have to find it. So of course, I'm not going to do this by hand. I'm going to put this in the graphing calculator and plug in 2. So in y equals, clear if you have anything else, 7.5 x squared minus 60.5x and then plus 254. It was 254, correct? Yes. Plus 254. And I plug in 2. 163. So the point in discussion is 2 comma 163. And now we have to find the consumer surplus if she makes 2 jumps. Okay. So in part A, the consumer surplus for 2 jumps is the integral from 0 to 2 from 7.5 x squared minus 60.5 x plus 254 dx minus this product, base times height. So 226. Okay, so this is 7.5 x to the third over 3 minus 60.5 x squared over 2 plus 254x from 0 to 2 minus 326. Okay, so 7.5 times 8/3 minus. So this is 4 divided by 2, which is 2, multiplied by that, 121, and plus 508 minus 326. And we're going to check the answer just to make sure. So I'm going to calculate with the calculator. Okay, so 7.5 times 8 divided by 3 minus 121 and plus 508 and minus 326. So I got $81. So if she buys 2 jumps at 163 per jump, she is paying 326, but she's really actually getting an extra of 81. Not money in the pocket, but from this expenditure, she's getting more than what she's paying. Okay, let's take a look and let me just double check to make sure. That's number 9, and the integral from 0 to 2, and it's dx and then minus 326, and the function was 7.5 x squared and minus 60.5 x and plus 254. When I hit enter, if I don't get 81, I have to go back to the drawing board. Okay, part B. Suppose the supply function for Aero Skydiving Center is given by S of x, which is 15x plus 95. Find the producer surplus if the center sells Beth 2 jumps. Okay? So in this case, the producer surplus is 326. Unfortunately, 326 is for the demand. This is not the equilibrium point. The number will not be the same. So I have to find S of 2. So this is 30 plus 95 is 125. So 2 times 125 is 250. 250 minus the integral from 0 to 2 from the other function, which is this, 15x plus 95 dx. So one more time. We needed to determine, in this case, if they sell her 2 jumps, they are getting paid 125. So 15 times 2 plus 95. Now, at 2 jumps times 125, that is 250. So then 250 minus the integral from 0 to 2 from 15x plus 95 dx. Okay. Let's continue that. So this is 250 minus 15, don't forget parentheses, plus 95x from 0 to 2. So this is 250 minus 4 divided by 2 is 2 times 15 is 30, and 2 times 95, 190. So 250 minus 120. So this is 130. And that's the consumer surplus. That's the producer surplus. Now, finally they're saying, find the equilibrium point and the consumer and producer surpluses at that point. Assume that Beth makes no more than 5 jumps. Okay? And then explain what the equilibrium point represents to both. Well, what it represents is what we know from 3 months ago. It's when everybody's happy. She's willing to pay, and they're willing to supply. That's what the equilibrium point represents. So let's look at part C. So first we have to find the equilibrium point where everybody is happy. And like before, the supply equals the demand. Okay, so the supply, where is my supply? So 15x plus 95 equals 7.5x squared minus 60x plus 254. Okay, so 7.5x squared minus 75x and plus 254 minus 90.
60.5.
I didn't copy the whole thing. You're right, there was some decimal point there. Yes, 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 thank you. Thank you very much. Thank you. Sorry about that. Let me check now everything. Yes, okay. So this is 0.5. So 254 and then minus 95. So that's a 9 and that's a 5 and that's a 1. Okay. Am I correct? 9. 9 from 4 is 5, and then 1. Correct. I'm going to use, of course, I'm not going to try to factor a quadratic formula. No, no, no. We're going to go to apps 9 and 7.5 is the leading coefficient, is negative 75.5 the middle coefficient, and 159 the free term. Okay, so then x equals 3 and x equals 7.1. So we're told that she does not make more than 5 jumps. I think it was 5, right? I'm just checking. That's not what I meant. Okay, yeah, not more than 5. So that's the only option. So x equals 3 jumps. Now I have to find the y coordinate. So the equilibrium point is 3 comma, and I go back here with 3. They are equal anyway. So 45 plus 95. 3 times 15, 45, 95. 140. Any questions? Yes, perfect. So now the product will be what she will pay, $420. So the consumer surplus at the equilibrium point will be the integral from 0 to 3 from 7.5 x squared minus 60.5 x plus 254 dx minus 420, and the producer surplus will be, oh, no, 420 minus the integrals from 0 to 3, 15x plus 95 dx. Any questions on this problem? Do we understand the consumer surplus and the producer surplus?
Yes.
Do we need more examples? I'm just going to put these in the calculator and get the answers just for this time. Do we need more examples, you think? Anyone? Or is this okay? Okay. Okay, I'm looking and making sure that I entered everything correctly. So this is 137.25. And now the other one, the producer surplus from 0 to 3, and from 15x minus 95, plus 95, sorry, and dx. And this is 67.5. Okay. Any questions? One more time, do we need more examples? Is that a yes? Is that a no? Anybody? I know Marcus said no, we can move on, but Anybody else needs more examples? Okay, in that case, we're not going to be able to finish, but we're going to start section tonight. We're going to start section 5.7, differential equations. First of all, what is a differential equation? It's an equation with the derivatives in it, at least one. So equations with derivatives. That's a differential equation. So here's an example. 2y plus y prime double prime minus 3y prime equals 4. This is an example of a differential equation. It has the function, doesn't have to have all of them. I just give an example. It has the function, it has the second derivative of the function, it has the first derivative of the function, and it's an equation. So this is an example of differential equations. We're going to look at simple differential equations and separable differential equations. So A, simple. The abbreviation is differential equations, DE. And part B, separable differential equations, in which we are going to separate the variables. We're going to get there hopefully next time. Okay? So today we're going to, for the next 15 minutes, we're going to look at simple differential equations. Okay. I'm going to share my screen and we will look at a few examples. 535. The first set of questions is really asking us, find the general solution and then the particular solution for the given initial condition. So let me just look at one example. Let's say 3. We are given y prime, which is the derivative of a function. We are given the derivative, and then we are told, remember, y of 0 is 4. When x is 0, y is 4. So let's start with that. And then you choose the next one. So 535. So y prime equals e to 4x minus x plus 2. Y of 0 is 4. This is nothing different from before. Nothing. Meaning, I'm asked to find y. Okay, so if I have the derivative, I would have to find the most general antiderivative. So when y prime is this, y will be, which function prime is that? Which is e to 4x over 4 minus, which function is this? Which function prime is that? X squared over 2 plus, which function prime is this? 2x plus a constant c. Nothing different from what we did in chapter 4. Okay. Now, I am told that there is a special or initial condition, it's called, meaning it will allow us to find c. This condition allows us to find c. When x is 0, 0, 0, but 1 fourth, and this is 4. 4 equals e to 0 is 1. This is 0, this is 0, plus c. So then c is 4 minus 1 fourth. So 16 minus 1, 15 fourth. All I have to do is plug it in. And that's it. Nothing new in this so far. In this section, nothing is new by comparison to what we covered in chapter 4. So e to 4x over 4 minus x squared over 2 plus 2x plus 15 fourth. And this is it. That's all we were asked to find. Okay, now your turn if you'd like. If not, I will choose. Let's practice with any other.
Can we try 5?
Yes, please. Let's try 5. Problem about page 12, number 5. And we have y prime equals 3 over x plus x squared minus x to the 4th. And the initial condition is when x is 1, y is negative 4. Again, we know that this is there to help us find the constant.